Hello everybody, welcome back to my channel. So this session is about TCB. So it is a part of TCP. So how TCB work in TCP? So I have already uploaded one session related to TCP, like how it works, how three-way handshake happened. So please watch part one and then watch this video so that we can understand the flow, actual concept, guys. I'm pretty much sure this concept is not available everybody, sorry, everywhere, but I'm going to explain and share with you guys. Okay. So TCB is transmission control block. Okay. So TCP, what is TCP, guys? So TCP is basically transmission control block. It's a block of memory. Okay. And for that memory, a space is allocated by CPU. Okay. See, whatever data sent between client and server, it is going to be some data information is going to store in the memory, and CPU is process that data, right? So this is the actual behavior of the we can say like systems, maybe our laptops or desktop, or we can say in between communication between client and server, right? So TCB is a transmission control block, and it's a block of memory, and for that a space is allocated by CPU to maintain a state information for a single TCP sessions. Okay, little once we'll move ahead, you will definitely understand what is TCP at the end. Okay, it's contain TCP socket informations, and creation of TCB, guys, transmission control block can happen in one or two ways. First one is active opens and second one is passive opens. Okay, so before moving ahead, let me go here and then we can understand it. Okay, so I just said like TCB is transmission control block is a fundamental data structure used in the transmission control protocol, that is TCP, to manage and maintain the state of TCP connections. Okay, each active TCP connection has its own TCB. Okay, which store all the necessary information about the connections. In short, I can tell you in TCB, all the information is going to be stored which is required to make the connection between client and server, like source IP, destination IP, source port, destination port, sequence numbers, and on the basis of that, accordingly, you're going to track the details. Okay, that is the reason, guy, TCP is connection oriented. It is reliable and retransmission protocols. But UDP does not have these features, guys. Okay, so whatever things happen, for example, during three-way handshakes, let me come here. Okay, yeah. So during three-way handshake, guys, okay, during three-way handshake, the TCB is initialized in both side, like client side and server side. Okay, and it is going to contain some details in TCB, like local IP address, local port. We can select source IP, source port, destination IP, destination port, sequence numbers, and same things happen with the other in, that is B side, server side. Okay, and whenever any changes happen, for example, client is sending scene and server is adding one on that scene and sending as acknowledge, that is going to be updated in TCB, transmission control block. So each and every information related to connection, related to TCP connection in between client and server is going to be stored on TCB. We can select block, transmission control block, for the record purpose, guys. Okay. Okay. For example, we have sending, for example, client is sending one data to the server, but server is not acknowledge that data. So that details is stored in TCB, transmission control block. Okay, server is yet did not acknowledge that data, and it's happened for these connections. Connection number, for example, one. So it is going to retransmit the data until getting acknowledged from the server, because it has a detail in TCB, transmission control block. Okay, so this is the use of TCB, guys. Okay. Similarly, B, that is server side, TCB will store its own details. Okay. Let's consider a little bit example also. For example, data is sent, a TCB update the sequence number and track unacknowledged data. So if data is sent from client to server, it is going to update that entry accordingly in TCB and it is going to track like, okay, data is acknowledged or not. Accordingly, it is going to maintain the entry in TCB, transmission control block. Okay. Same for B. For client, we can select for server side B, TCB update the acknowledgement number as it received the data. So if data is received, accordingly, it's going to be upload the entry in TCB. Okay. That is transmission control block. Okay. If connection is terminated, when the connection is closed, guys, when the connection is closed, the TCB is cleared and resources are used. So for example, we have built on connection between client and server, and after that we have some sent some data from client to server. And after that, if connection is terminated, if connection is closed with the help of pin is the flags in TCP which is used to close the connections. That is the good way to close the connections. So after connection close, it is going to clear. It is going to clear the entry from TCB, transmission control block. Okay, it will not maintain it because that connection is already closed. So during close, it is not going to maintain that in TCB. Okay, so that it is going to maintain again next sessions in TCB. So this is the beauty, this is the actual menu of TCB. So it is going to contain each information which is required to make the connection between client and server. We can select during three-way handshake. And it is going to track all the information between client and server, and TCB is going to create on both end, that is client end and server end. Okay. So the TCB ensure that TCP can reliably deliver data, manage retransmission, and handle flow and congestion control effectively. So this is the meaning of TCB, guys. I hope you guys really understand the meaning of TCB, transmission control block. Okay. Let's move on the active opens and passive opens, guys. Okay. Then we'll try to so little bit about three-way handshake, and then we can close this session. Okay. So what is the meaning of TCB? TCB create TCB active opens and TCB passive opens. So for example, so we have built one server, and this server is listening. The server is configured for the telnet 23, and it is listening on the port 23. It is built today, but since 2 days, no one is using it. Okay, no one is using it. So TCB has all the details. Like in transmission control block, it is all the details like ports and IP, everything. But no one is using. No one is initiating the connection to this server. So that will be the part of TCB passive open, because it is not in use. It is waiting like someone send request to me so that I can respond accordingly. So that is called TCB passive open. TCB active open means, guys, this is your PC or maybe my laptop, your laptop, and we are in the position to initiate the connections. We are on the position to do the telnet of this server. So it will be the part of TCB active open, because we are active to communicate with the server, telnet server. And accordingly, TCB is going to maintain the entry in the TCB, we can say transmission control block, like source IP, destination IP, source port and destination port, it is going to maintain it. So that is the part of TCB active open. Okay. Now let's move up three-way handshake. So for examples, why, why TCB, we can select why TCP three-way handshake is required, guys. Why it is important? Let's understand. Let me first erase it. Okay. For examples, we are searching like google.com on our laptop, google.com. And we are telling to Google, hi Google, we need, we need your homepage. And that request will go on the HTTP, right? HTTP get. HTTP get. The HTTP is going to tell to TCP, I need the information of user. So how TCP know the information of users? How TCP know the information, we can say like of client? So that is possible with the help of TCP three-way handshake. Okay. Accordingly, it is going to deliver the data. So Sender is going to initiate one sequence, SYN packet. Sender is going to initiate one SYN packet towards receiver side in this direction. Okay, let's consider X. Receiver is received the sequence number which is sent by sender. Okay, the receiver will generate its own sequence number, that is Y, and it is going to add one on sender sequence number, that is X, and it is going to be sent as a acknowledgement. So whatever sequence number sent by sender, receiver is going to add one on that sequence number as acknowledge, and it is going to generate its own sequence number in the direction of sender. And this is the first time. So this sequence number is going to continue during all the process. This is the first stage. It is not going to initiate again and again. It is going to initiate again once this connection is terminated. Okay, so connection is built, data is get transfer, and the connection is terminated. Connection is closed. Entry is removed from the TCB, that is transmission control block. Then it is going to, and later when client want to communicate with server for the other purpose, then others, other three-way handshake will happen. Other sequence number will be generated. Okay, so when sender is sent X, a sequence number in the direction of receiver, receiver is received it, and receiver is going to generate its one sequence number, that is Y, and it's going to add one on sender sequence number, that is X plus one, as a acknowledgement, so that sender will know, okay, whatever sequence number I have sent, receiver is received that sequence number. Okay, and it's going to generate its one sequence number and send in the direction of the sender. Then sender is going to add one on the receiver sequence number, and it will send as a acknowledgement, that is Y plus one. Okay, and then receiver will understand, okay, I have received the acknowledgement, that is Y plus one, from the sender, and then TCP will be established, guide. So this is the three-way handshake process. And all the informations related to during three-way handshake contain in TCB block, transmission control block, guys. So I hope you guys understand three-way handshakes plus TCB and how TCB is useful in TCP handshake, in TCP connections. Okay. So if you really like my efforts, please share, like, subscribe as much as possible. Let's meet on the next session. Thank you very much, everybody. Thank you for your times.